So now we discuss the problems based on mole concept. See the first problem here. So what weight of potassium chloride formed on heating 12.125 grams of potassium chlorate, and also calculate the weight of oxygen liberated in the reaction. So for this type of problems we must know about the reaction. So here the reaction is heating of potassium chlorate. So what is the reaction of potassium chlorate heating? On heating of potassium chlorate, we will get potassium chloride and oxygen. So this reaction is generally used in the preparation of artificial oxygen gas. Now, for the problems we must take the balanced equation. Here in this problem, we need to calculate two terms, that is the weight of KCl and the weight of oxygen. So first we calculate the weight of KCl. You see calculation of weight of KCl. So according to the balanced equation, 2 moles of potassium chloride can release 2 moles of potassium chloride. 2 moles of potassium chlorate releases 2 moles of potassium chloride. So according to this balanced equation, 2 moles of KClO3 can release 2 moles of KCl. Here we need to find the weight. So weight find out cheyamannadi, we convert the moles into weight. If volumes lo adute answer, we need to convert the moles into value. 2 moles means 2 into its molecular weight. So KClO3 molecular weight 122.5. So according to the balanced equation, 2 into 122.5 grams of KClO3 releases. KCl also must be calculated in weight. 2 into its molecular weight 74.5 grams of KCl. Means 2 into 122.5 grams of potassium chlorate on heating releases 2 into 74.5 grams of KCl. Here we need to find, in the given problem, 12.25 grams of KClO3 can produce how much KCl? Simple. Can produce how much KCl? So by this calculation, we will get 7.45 grams of KCl. So this is the first part, that is calculation of weight of potassium chloride. Okay. Next we see the second part in this problem, that is weight of oxygen calculation. So according to this balanced equation, two moles of KClO3 can produce 3 moles of oxygen. So 2 moles means according to weight, we must convert into weights. KClO3 given in terms of weight. The oxygen also asked in terms of weight. That's why here we convert the moles into weight. So 2 into 122.5 grams of KClO3 can produce, oxygen means 3 into 32 grams of oxygen. Simple. Now 12.25 grams of KClO3 can produce how much oxygen? So here we get 4.8 grams of oxygen. Okay, last step. So next problem. So calculate the weight of calcium oxide. It is also known as lime. Required to remove the hardness of 10 power 6 liters of water containing 1.62 grams of calcium hydrogen carbonate in 1 liter. So this type of problems related to hardness of water. So already we know what are hard water. The hard water means which does not give a good lather with water, with soap solution. The soap solution though good perfect lather ivvakapothe, that is called hard water. So what is the which salts are responsible for hard water? The presence of calcium hydrogen carbonate, magnesium hydrogen carbonate, and calcium sulfate, magnesium sulfate, calcium chloride, magnesium chloride. So these are the main salts which are responsible for hardness of water. But here it is given that calcium hydrogen carbonate. Actually, calcium hydrogen carbonate is responsible for temporary hardness of water. So how we can remove the temporary hardness of water? Just by heating. Or we can remove the temporary hardness just by reacting with nothing but mixing of that water with lime. So what is lime? Here it is given lime. So balance the equation. So this is the reaction takes place in the removal of temporary hardness of water, which is caused by the presence of calcium hydrogen carbonate. అంటే ఇక్కడ ఈ వాటర్ని ఇప్పుడు కాల్షియం హైడ్రోజన్ కార్బోనేట్ వాటర్లో ఉంది. వాటర్లో ఉన్న ఈ కాల్షియం హైడ్రోజన్ కార్బోనేట్ రిమూవ్ చేయాలంటే జనరల్లీ వి యూజ్ లైమ్. ఇప్పుడు వాటర్ని ఈ లైమ్తో కంబైన్ చేసినప్పుడు దెర్ ఇస్ అ ఫార్మేషన్ ఆఫ్ దిస్ రియాక్షన్. The calcium hydrogen carbonate, which is responsible for the hardness of water, is removed in the form of calcium carbonate. So calcium carbonate precipitate outundi, and even in the presence of calcium carbonate, there is no hardness of water. Okay, so now the problem is, in 1 liter of water sample, there is 1.62 grams of calcium hydrogen carbonate is present. Okay. In a sample of 1 liter, 1 liter of water has 1.62 gram calcium hydrogen carbonate. But we need to calculate the amount of calcium oxide required to react calcium hydrogen carbonate present in 10 power 6 liters. Just మనకి ఇక్కడ 1 liter sample లో ఎంత calcium hydrogen carbonate is given. కానీ ఇక్కడ హార్డ్నెస్ రిమూవ్ చేయాల్సింది జస్ట్ ఈ 1 liter నుంచి కాదు, ఇక్కడ రిమూవ్ చేయాల్సింది 10 power 6 లీటర్లో ఉన్న హార్డ్నెస్ రిమూవ్ చేయాలి. అంటే ఇప్పుడు 1 liter contain 1.62 grams of calcium bicarbonate. But how much calcium carbonate is present in 10 liters of water? 1 liter has 1.62. Simply, the 10 liter has 10 power 6 liter has 10 power 6 into 1.62 gram of this calcium hydrogen carbonate. Now we have to calculate the amount of calcium oxide the amount of lime required to react 10 power 6 into 1.62 grams of calcium hydrogen carbonate. Okay. Now see, according to the balanced equation, 1 mole of calcium hydrogen carbonate can be removed with the help of 1 mole of lime. Here it totally given in terms of weights, grams. We are also calculating weight currently. We will convert them into weights. So according to the balanced equation, 1 mole of calcium hydrogen carbonate need 1 mole of CaO. Here 1 mole of calcium hydrogen carbonate means how many grams? Its molecular weight. So 162 gram of calcium carbonate need calcium oxide means 56 grams of CaO. According to this equation, 162 grams of calcium hydrogen carbonate remove cheyalante it needs 56 grams of calcium oxide. In the problem it is given how much amount of calcium hydrogen carbonate? 10 power 6 into 1.62 grams of calcium hydrogen carbonate required. How much CaO? So finally here we get so 10 power 4 into 56 grams of CaO. 10 power 4 into 56 grams of CaO is required. Malaki answer must be in weight kabatti no need to convert into moles. Here 10 power 56 into 10 power 4 grams of CaO is required to remove the hardness obtained by water due to the presence of this much of 10 power 6 into 1.62 grams of calcium hydrogen carbonate. Okay. So we see the other problem, third one now. Here the reaction is given 5H2SO4 plus 4 zinc gives 4 Zn plus 2 H2S 4SO4 minus 2 and H2. So the question is how to find what is the behavior of H2SO4. What is the behavior of H2SO4 in this reaction? So we know that the H2SO4 has different characters. It can work as a oxidizing agent. It may work as a dehydrating agent, or it may work as a acid. Anything is possible with H2SO4. Now the question is, so what is the behavior of H2SO4 in this particular reaction? So if you observe the reaction, here Zn becomes Zn plus 2. Zinc is oxidized to Zn plus 2. So zinc is oxidized to Zn plus 2 by reacting with H2SO4. It means that therefore we can say H2SO4 is an oxidizing agent. Means in this reaction H2SO4 act as oxidizing agent. Means H2SO4 itself undergoes reduction. So that is like this. In H2SO4, the sulfur oxidation number we know that plus 6. And the sulfur part is here H2S. Here it is having minus 2 oxidation number. So sulfur H2SO4 to H2S. Oxidation number decreased. So itself it is reduced. So it is reduced means it acts as oxidizing agent. So it oxidizes the zinc into Zn+2. There is no other option. Means in this reaction H2SO4 acts only as oxidizing agent. Okay, clear?
Okay.
So see the same type of problem, some different reaction. H2SO4 react with zinc forming Zn+2, H2 and SO4 minus 2. Just like similar to the earlier problem. So I have to find what is the behavior of H2SO4. Here also the same. Zinc becomes Zn+2. It is oxidized. So it is oxidized by reacting with H2SO4. So simply we can say H2SO4 is oxidizing agent. Here other important one, unlike the before problem, here SO4 minus 2 form and also there is the presence of H2 gas. Here we need to think how H2 gas is formed. The H2 gas is formed only from the H2SO4. So it indicates that H2SO4 2H plus forms SO4 minus 2. These two H plus ions undergoes reduction forming H2. Means if the product's hydrogen is present means there is a formation of H plus ions. The H plus ions formed means there must be, they should be came from H2SO4. Means in this reaction hydrogen is formed from H2SO4. Means here hydrogen is released. The hydrogen ions are released from H2SO4. The hydrogen ions are released. Therefore, we can say H2SO4 is worked as acid. From Lewis theory, we can say it was defined that the compound which can release H plus ions, it will be treated as from the normal acid base theory. So we can say the compound which can release as H plus ions, that will be treated as acid. So here H2 formed means H plus ions are released. The H plus ions are released must be from H2SO4. So here H2SO4 releases H plus ions. That's why it was treated as acid. Means in this reaction H2SO4 acted as both oxidizing agent and as acid. The earlier problem it works as only oxidizing agent. But here in this problem it works as oxidizing agent and also works as acid. Okay. So see the similar other problem. Here glucose C6H12O6, glucose or fructose. In presence of concentrated H2SO4 forms 6 carbon atoms and 6 H2O. We need to find so what is the behavior of H2SO4? So in this reaction, the oxidation number of carbon is no change. The oxidation number of any element does not change. In this reaction, carbon oxidation number in the reactants 0. Here also 0. Hydrogen oxidation number here +1. Here also +1. Here oxygen oxidation state -2. Here also oxidation state of oxygen is -2. I mean there is no reduction and no oxidation of the given compound. But what is the change? The glucose C6H12O6 forms 6 carbons and 6 H2O. Only the water molecules are removed from the compound. So water molecules are removed out from the compound. That's why here H2SO4 acts as dehydrating agent. In many reactions, concentrated H2SO4, even in the preparation of alcohols, in the many reactions, H2SO4, concentrated H2SO4 acts as dehydrating agent. In this reaction, H2SO4 acts as only dehydrating agent. Okay, clear? So we see the other problem which is similar to the earlier one. Again, here in this reaction, H2SO4 reacts with zinc carbonate forming Zn plus 2 CO2 SO4 minus 2 and H2O. Here also we need to find, so what is the behavior of H2SO4? Here if you compare zinc, what is the position of zinc with Zn plus 2? So in the products also the position of zinc is Zn plus 2. Means there is no change in the oxidation number of zinc. Means there is no oxidation, there is no reduction takes place in the zinc. Even there is no change in the oxidation number of carbon, in the oxidation number of oxygens. But here the H2SO4, there is a formation of H2O and CO2. So how it is possible? The H2SO4 releases H plus and SO4 minus 2. So this is this SO4 minus 2. And these two H plus ions reacts with the carbonate ion of it. Carbonate ion. Forming H2O and CO2. Means there is a formation of H2O and CO2 takes place only due to the reaction of these two H plus ions with the carbonate ion. This carbonate ion is from zinc carbonate and these two H plus ions are released from H2SO4. Here the compound which releases H plus ions is treated as acid. So therefore we can say in this reaction H2SO4 acts as an acid. It not works as oxidizing agent because no compound is oxidizing here. It does not work as dehydrating agent. And H2O is not removed from a particular compound, just is formed. In the earlier compound glucose is exactly removed from the glucose, that's why it's called as dehydrating agent. Here H2O is formed by reacting of two H plus ions with carbonate ions, and this is formation of H2 and CO2. So these H plus ions are released from H2SO4. The compound which releases H plus ions are treated as acids. Therefore, in this reaction H2SO4 acts as acid. The remaining problems we see in the next class.